In this video, you will become an expert at graphing a sine and cosine function using the amplitude and period. Our sine and cosine functions are sinusoidal functions. One important property is that they're periodic. What that means is that the values of the functions will be the same for a given interval of the domain. This interval we call the period. So let's go ahead now and define cycle, period, and amplitude. The cycle is the portion of the graph from one point to where the point repeats itself. The period is going to be the change in x corresponding to one cycle. This is also going to be the distance or length along the x-axis in one cycle. The amplitude is going to be the vertical distance from the midline to the highest or maximum or lowest point. Let's go ahead and see what the basic shape is for the two-period sinusoidal functions sine and cosine. Below here we've made a table of values. What we want to do is we want to take out our graphing calculators and put it in the radian mode. So if I turn it on and I go to mode, I want to scroll down and press enter on radian, so that's highlighted. Then we want to take the cosine of each of these different radian measures. You might recognize that each of these values are the 4 quadrangle values of the unit circle for radians. That's why we're going to use these values as our 5 critical points. So the cosine of 0, if I evaluate that, I get a value of 1. What this means is that because I plugged in different x values and got a y value, the ordered pair would be 0, pi if you want, 1. Next, we can do the cosine of pi over 2, so at 90 degrees. That gave me a value of 0. So as an ordered pair, I'm at pi over 2, 0. Then we can do the cosine of pi. That gave me negative 1. So at pi, or 180 degrees, I'm at a value of negative 1. So the ordered pair is pi, negative 1. For a cosine of 3 pi over 2, I get a value again of 0. So at 3 pi over 2, or 270 degrees, I'm at the ordered pair 3 pi over 2, 0. Then when we go back to 2 pi, that, remember, is the same value as 0 pi on our unit circle. So I'll expect this to be the same value of 0, which is 1. The cosine of 2 pi is 1. So at 360 degrees, or 0 degrees, the cosine of there is 1. So I'm at the ordered pair 2 pi, 1. If I now go ahead and plot these values on an xy axis, we can get our basic shape for the cosine function. So along here horizontally, this is going to be our x-axis, which for the parent graph is also our midline. Then going vertical, of course, is our y-axis. Next, I want to put our max and our min values on. The largest value I evaluate to is a value of 1. The smallest value is a value of -1. We also hit the midline of 0. Then I want to plot my 5 critical points. These are again the 4 quadrangle values for this period. So I have 1, 2, 3, 4 sections. And at first we were at 0, so that would be right here. Then we went to pi over 2. Then we went to pi. Then we went to 3 pi over 2. And then 2 pi. If we now plot the order pairs that we have, we'll get our shape. So at 0 pi, I was up at 1. At pi over 2, we were at 0, the midline. Pi, -1. 3 pi over 2, 0. And 2 pi went back up to 1. Drawing in our curved shape through our 5 critical points, we have the shape for cosine. I'd like you to notice that at these 2 values that are maximums, the function bounced. It changed direction. This will always happen along the max line because our graph should never go above the max line. The same idea happens down here at the min line. We should never go below the min line, the minimum value, and that's why again you see it bouncing. Please now pause the video and do the same idea for the sine function below. Please now check your answers for the sine graph. Notice, unlike cosine, sine starts on our midline and therefore ends on the midline. It then goes up to a maximum, back to the midline, down to a minimum, and then again to the midline. With both functions, we alternate at a max or min and going to the midline. Let's review some key points on the next page. So, the cosine graph is going to start from your maximum point. Or up your amplitude. Please know if we have any shifting, that could change. Now the sine graph will always start on our midline. For the parent graph, that was the x-axis. So if we don't shift, that'll be the x-axis. Then, for both the parent graphs, the sine and cosine's amplitude was only 1. We only went up 1 or down 1 from the midline. And the period, the length we traveled along the x-axis, was a length of 2 pi. Now, these are both true for the parent graph. As we can see below, that's not always true for every function. So let's look at graph A. I can see that this is the sine function graph. If I want to look at the actual graph itself, sine, remember, starts on the midline, so it must be starting here. Then travels up, back to the midline, to a min. If we had the full picture, we would have seen it going back up to the midline. If I want to look at my amplitude, I have to look at how high from the midline or how low from the midline my max point or my min point is. Here we're only going up a unit of 1 or down a unit of 1, and so my amplitude is just 1. When I look at B, here the sine function again starts at the midline, and if I go up, midline, min, and back to the midline, I can see that now I'm going up to a maximum by traveling 3 units. I'm also going down to a minimum by traveling 3 units. So the question now is, what does that factor of 2 do to the graph B? And what does the factor of 3 do to graph B? So I can see here that that value of 3 was how far our amplitude was. By multiplying the function by something, we change our amplitude. Now, the factor of 2 had to have done something else. If I look at my period in the parent graph, this would have been ending at 2 pi. So from 0 to 2 pi, I have a distance of 2 pi. In graph B, though, I start at 0 and I end at pi. And so that 2 cut the period in half. It divided the normal period of 2 pi by a factor of 2. So we can conclude that if we have an equation of the form y equals some value a times the sine of some value b times x, such as in our y equals 3 sine of 2x, the 3 will stretch the graph vertically and the 2 shrink the graph horizontally. A, if you remember, is going to represent our amplitude. And so here the 3 was stretching it vertically. B again is going to tell us the number of cycles in a normal 2 pi length. So that's why if we take 2 pi and divide by B, we get our period. That's also, since we're dividing, why it shrinks the graph horizontally. Horizontal because, again, the period was the length along the horizontal x-axis. You can also write this with the cosine function. If you had y equals a times the cosine b of x, a again would tell us our amplitude, and b would tell us how much to shrink the function by along the x-axis. So now let's look at it in terms of an example. In example 1, I am given y equals 4 times the cosine of x. I will always ask you to identify your amplitude, your b value so that you can figure out your period, a maximum value and a minimum value, which we can get once we graph the 5 critical points of one period. So let's start with A, the amplitude. Again, this 4 in front of the cosine is going to give me the amplitude. So if I go ahead and put a y-axis onto the x-axis that is already on my graph, I know that I'm going to have to go up an amplitude of 4 to be able to reach my maximum, and down an amplitude of 4 to meet my minimum. The midline here will still be the x-axis at 0 since we don't have any shifts. It helps some students to draw in the min and max lines, but that is not a requirement. Next, let's look at our period. To be able to find the length that our cycle goes, we need to see how many cycles there are in 2 pi. Since there's nothing written by the x, I can assume that b is a length of 1. Meaning, if I do my normal 2 pi period and divide by 1, I get a length of 2 pi for my period. What we want to do with that is we want to divide that length into 4 equal sections, just like our unit circle is divided into 4 equal sections. So I can do that by dividing up my x-axis into 4 sections. If I start at 0 and travel a length of 2 pi, I know I'm going to end at 2 pi. To figure out these other values, I want to think about each section's length. Each section is going to be obtained by taking my period and dividing it into the 4 equal sections. So here, if I take 2 pi and divide it by 4 and simplify, each section's length is pi over 2, which, if you guys recall from the unit circle, is the same thing as pi over 2 up at 90 degrees, adding on another pi over 2 to get to 180 degrees, adding another pi of 2 to be at 3 pi over 2 or 270 degrees, and then all the way back up to 2 pi at 0 degrees or 360. So if I'm at 0 and only travel one section's length, I've traveled pi over 2. From here, if I go another half pi, I've done 2 half pi's, or pi. 1/2 plus 1/2 is 1. If I travel another length, I'm at 3 pi over 2. And if I travel that last length, I'm at 2 pi. Once you have your x and your y axis labeled, all you have to do is apply the cosine shape. Cosine, if you remember, starts up your amplitude at a maximum. So here I should be starting at 4. Then it always alternates midline, min, midline, max. And then now I can draw in that kind of U cosine shape. Again, remembering to bounce at my max and my mins. This also allows me to identify a max and a min. With cosine, there's going to be 2 maximums, and I don't care which one you give me. I usually will just write the first one. So it's at an x value of 0 and a y value of 4. My minimum here is at an x value of pi and a y value of -4. Please now pause the video and complete example 2 on the next page. Please now check your answers for example 2. You'll notice that we had 2 multiply times the sine function, and so that's why my amplitude is 2, and I went up and down 2 from my midline of the x-axis. There was also nothing multiplied times x, so I assumed b was 1, meaning that there was only one cycle in each length of 2 pi. So to find my other critical points, I took the period 2 pi and divided by my 4 equal sections. That meant each time I wanted to add on pi over 2 to the one before. If you're trying to do this on your calculator, you basically want to add things without the pi. So from 0, if I add 1/2, I get 1/2 pi, pi over 2. If I add another half, I get 1 pi. Add another half. 3 pi over 2. And lastly, add a last half, 2 pi. Remember, this end point and your beginning point should always be the length of your period. If I do 2 pi minus 0, I should get 2 pi. Please pause the video and figure out all the different information for example 3 and see if you can figure out the length for each section and put that on the x-axis, or here we replaced x with a theta. So here my amplitude was only 1, but since b was 4, to find my period I had to take 2 pi and divide it by 4, because I should have 4 cycles in each length of 2 pi. That gave me a period of just pi over 2. So to find each section's length, so further dividing my period by 4, I had to do pi over 2 over 4, which is basically me and my calculator doing 1/2 divided by 4, and then again math frac to make it a fraction, and knowing that that's pi over 8. To figure out these values here, again I'm just taking my starting point of 0, which if we have no shift should be where you start, and adding on that section length each time. So obviously 0 plus an eighth is an eighth. If I add another eighth, and again math bracket, I get 1/4, pi over 4. Add another eighth, math frac, 3 pi over 8. And add your last eighth, pi over 2. Now go ahead and apply your sine function for example 3. Also, figure out a maximum and a minimum point. Here, I had a maximum at pi over 8, 1, and a minimum at 3 pi over 8, -1. Remember that the sine function starts on your midline, and then again, if there's no shifts, goes up to your max, alternate back to the midline, down to a min, alternate back to the midline. Please now pause the video and complete example 4. Please now take a moment and correct your work. Notice that because b was a value of a half smaller than 1, we got a period bigger than 2 pi, meaning that in just one length of 2 pi, I only get half of a cycle. So that's why our period is going to be longer. And again, I can figure this out by taking 2 divided by a half in my calculator. Remember, whenever you put fractions in your calculator, you need to use parentheses. Please now complete tonight's homework.